Hey YouTube, it's JP Dillon. Today we're going to look at a bit of a rare set. This is a Toshiba model C321 13-inch color TV. This was made sometime around 1970-71. It does use a tube chassis. I don't recall whether it uses a hybrid system with both transistors and tubes or just tubes. But this is one of those sets that is extremely rare. You're very unlikely to find it. You're more likely to run into one of those all-metal 14 or 15-inch color Zeniths than you are this. So I was very fortunate to come across this because this is one of those things I collect, is early color Japanese portables. This I picked up at a yard sale. It was sitting in the back of the guy's garage. I pointed it out and say, "Hey, you want to sell that?" And he says, "It doesn't work." And I said, "Okay, so what?" And he says, "Well, just take it." Didn't have to pay for it, so I'm absolutely stoked. However, he says it doesn't work. I really don't know what that means. It can mean a whole variety of things, but we're going to try to find out what's not working about it and see if we can't go about fixing it. So, just as a brief rundown, let me pop this out of the camera holder here. The speaker's on top, which is kind of weird. Those are normally on the bottom. You've got your VHF, UHF, the contrast, pull for AFT, pull on volume, and on the side you have a plethora of service controls: tint, brightness, color, vertical hold, horizontal hold, and a headphone jack for your private listening. This is not a light set. This is about 65 pounds. I wouldn't really call it portable. It's more like a luggable. And as you can see, it's very deep. The cabinet goes back really far. Let me see if I can move it around here and rotate it. Oh, it is heavy. And we can take a look at the back. And so there you are, C321, lot number 72F. You can see we've got controls for AGC, vertical linearity, vertical height. You've got your screen controls back here, a safety interlock. That's about it. There's really not much else to it that's user adjustable. So what let's do is plug it in and see what it does or doesn't do. I really have no idea at this point because I haven't done anything to it yet. The cord's a little brittle, but it's not breaking yet. I'm just going to plug this in here. And we'll turn the backlight off so that maybe we can see the screen a little bit better. Turn it on and see what happens. I hear sound, so I guess it's a hybrid. Nothing yet. Let's see now. Saw something on the screen. There we go. Alright, so we have a vertical failure. It looks like it's trying to do something because I do see scan lines up here. It's coming and going. So that's what's going on with it. We've got a vertical output failure of some kind. So let's get the back off and take a look inside and see, get a look at the chassis layout. And where we need to look next is obviously the vertical circuit. Okay. We've got two screws that hold the antenna block in. Got two top screws here for the cabinet. I'm going to guess that the other two are on the bottom somewhere. Yeah, they're down here at the bottom. This is a modular chassis, or at least it should be, which you'll see in a moment. And let's see if this just comes free. Just thinking about it. Let's release the 75 to 300 ohm adapter. And there it is. So this is kind of cool. It's a modular chassis with tubes. Very cool. And just looking at stuff here, let's let's see, you've got chroma 1, chroma 2. What are you? Probably IF. And you've got color with a, or that's probably video. It's got a big old delay line on it. That's a pretty fat tube, so I'm assuming that's your vertical output. And then here you've obviously got your horizontal output and your damper. And then in there is the high voltage cage. That's your convergence controls up there. So let's see if the inside has any nomenclature about the tubes or something like that. Well, it did anyway. Alright. So I'm going to assume that this is probably your vertical here based on the tubes. Let's just yank one and check it here. See what you are. Yep, 10CW5. That's a vertical output tube right there. You've got that one. Come on. Got these little clips here. And then you've got this one. What is this like? It looks like a 12BH something or other. Nope, 8CG7. That's an oscillator. That's typically used as a horizontal oscillator though, so that's different. Of course, we don't know if this is being a 9-pin tube, the oscillator or the damper. Don't really know. And that's strange there that they got the tube facing inwards rather than out. Up there's your damper back there. And then that's your horizontal output, or oscillator and output, I assume. So that was in fact the vertical oscillator. This little thing that came off here for continued perfection, or yeah, perfection. Protection against fire replaced with the same type fuse. Let's take a peek inside of the high voltage cage, which is already loose. That flyback's nice looking. Only a little bit of cracking and wear on the case. Not burnt windings. It's pretty looking. 3AT2 rectifier. Sounds about right for a color set. And then back there we obviously have electrolytics and things. .37 OAYB22. This is probably one of those low focus voltage CRTs. Not easy to find if they're bad. We saw that there was mostly a red raster, so I'm kind of concerned that the tube might be a little tired. Maybe we'll stick the Beltron on it after we figure out what's going on with the vertical. So we need to do some troubleshooting on the vertical, and it's probably best that I draw out the vertical so you can understand what I'm going to try to do here. Now this is a very, very simplified drawing, and circuitry varies enormously depending on who makes it, how it's made, etc. But basically with every vertical circuit you've got an oscillator which derives a waveform for the vertical scanning frequency, and then you have an output tube which is usually a Class A amplifier. And the Class A amplifier fires into a primary of an output transformer which has a high impedance, and then that goes to the secondary of the output transformer which has a low impedance that fires into the yoke windings, which then draws the picture on the screen. So in order to troubleshoot this, you have to determine where the waveform stops. Now obviously the first two things you do is you check the tubes and make sure the tubes are good. If the tubes are good, then you see if you're getting voltage here. If you're not getting voltage here, then it's assumed that either you're missing B voltage or this winding, the primary on the transformer, is open, which is bad juju. Can't really do much about that except replace the transformer. If you've got voltage here, you check and see if you have screen voltage from your vertical size pot, make sure that's not open. If that's good, you make sure that you're getting waveforms here at the grid, which would come through a coupling capacitor from the oscillator tube, which is supposed to generate the waveform. So then obviously you'd see if you've got plate voltage for your oscillator tube, which I didn't draw in a supply voltage line here, but that's what that is. And then make sure you've got voltage on your control grid and then your screen grid. So schematics help, but you can usually, if you have an understanding of the circuit, be able to troubleshoot what is really causing it. So the first thing we're going to do obviously is test the tubes and see if the tubes are okay, and then if so, then we'll yank the modules out, make sure the soldering on the back of the sockets is good, make sure that I have B voltage going to the plate connection on the 10 CW5, and then obviously the oscillator as well. And we're going to hope that it ain't the transformer, because if it's the transformer, we got a problem. And then we need to derive a way to make this transformer work. But right now, let's start with the basics. Let's test the tube. Alright, so out comes the B&K tube checker. And the first thing we're going to do is test the oscillator and see if the oscillator tube's good, which is, that's an 8CG7. You could also test a 6CG7. The only difference is the filament voltage. CG7. So it's a two-section, plate voltage at 74, or sensitivity at 74. It's not the plate voltage, obviously. 74 in socket 7, and 8-volt filament. And we'll see if our oscillator tube responds. The fact that it's not a 6-volt tube tends to suggest that this is a series string set. Otherwise, they pretty much have consistent values all the way around. I can see the filament lighting over there. Can't really see it very well on the camera. Check for short. Emission is tired, but that shouldn't keep it from starting. You'd have very poor vertical, but I think you'd have something. So I may replace that. It's not great emissions, but tubes can be way down there in emission and the circuits still work. But there's no short and there's no grid leakage, which is good. So the next thing we do is move on to the 10CW5. At least I think that's, yeah, 10CW5. And this one's a specialty socket. So voltage at 10. E, C, A, B. Blank, F, blank, and D, C, A, and 1. And we're using socket 29. So let's see. If that works. Filament's lighting. No short, and we have really good emission. So the fact that the tubes are good, excuse me, well, The fact that the output tube is good is a good thing. Oh, I have the sensitivity set too high. So there we go. So the output tube isn't great either. But again, I don't think this would kill the sweep. This would just make it not all that great. It would be really shrunken down and you'd have to crank everything up to make it work. But I don't think that the tubes are the culprit. The tubes test, they have some emission left in them, which means the performance would be poor, but it would still work. So I think we need to do some further troubleshooting, and I think what I'm going to do is yank the modules on the back of the set, and we're going to examine the tube sockets and things and make sure that everything's properly soldered. Alright, so what we have to do is get this loose, this board here. And I already see a discolored resistor down there, so I kind of wonder about that. And we're going to remove this connection. It's the only one that sticks up there, so it's pretty easy to remember. Squeeze on this a little bit. And I can see that this isn't going to cooperate with me very well. Let's see if I can get a pry tool underneath it. Not so much. I don't want to bust that delay line there, so I got to be really careful to take that apart. I'm going to move this forward a little bit and up and see if I can pry underneath. Get that out. Yep, there's one side. And let's see if I can get the other side out. There we go. Squeeze. Come on now. I know you're not that crippled. There we go. So the module comes out. And then what we do here is we take a look at the module. And we see if there's anything on here. Of course my camera's not going to hold true now. There we go. See if there's anything on here obvious, like a broken connection on a tube socket. And there, of course it's not going to macro focus here. So let's zoom in on this if we can. Let's kill the glare. I don't know if you see that there. Broken connection on the plate. That's the plate of the oscillator. And if we push on it a little bit, tries to separate from the board. So that's a point of concern. Is that the cure? I have no idea. I just know that that connection there for the oscillator is not happy. So I am going to resolder that socket. In fact, I'm just going to do both. Remember, kids, tubes and circuit boards don't mix. But everyone was doing circuit boards in the 1960s and 70s because it was inexpensive. Circuit boards with solid state make sense. You can bang them out really quick, and they're for the most part low voltage, so there's not a lot of heat and they're a little more reliable. But tube stuff like this, no way. And again, I have no idea if this is actually going to cure the problem. But it's worth a try. I'm also going to do the output tubes here, or tube, because although I don't see any obvious signs of death, It doesn't mean that these sockets aren't breaking loose from the board. And there's this connection here, which is also somewhat questionable, that TP301, but it's a test point, so I don't think that that has any real significance. And then we'll take some measurements. Let's see, the 307 or 308 or something like that looked like it was burned up. Okay. So with those resoldered, the next thing I'm going to do is just check some component values and see if anything obviously sticks out. And then we'll check the pots too. The vertical pots could be touchy or open. You've got two electrolytics here. Probably cathode bypass. Has 680K. This should be like, yep, 56K. This should be a 10K or 100K. Oh yeah, yellow stripe, 100K. That's about right. There should be a 560. Yep, 569. And this should be like a 820. It's 829K. 2.2K, that's 2.35, and 3.33K, so it's 37. And then you've got this big dropper resistor here. This looks like a 56K dropper, 54.49. And then you've got another one down here, another 33K. It's pretty happy. And then this one down here, 2.2 meg, 2.48. And 227K, it's 2603. And you've got this guy down here, which looks like 430 ohms from what it says here. 420, it's close enough. In circuit, you're not really going to tell. So we've got two electrolytics here. This is a 33 microfarad. This is a 100 microfarad. Probably cathode bypass stuff. They could be messed up. And then let's just check and see if these aren't obviously shorted. Doesn't mean they're not leaky, but they could be nothing red there. Just checking for the obvious at this point. Looking for anything that could be a short circuit. So those pretty much all charge up. Let me get the, well actually, let's just check the electrolytics for shorts just for grins and giggles before we grab the ESR meter. That charges up. That charges up. No shorts there. Let's grab the ESR meter and see what the condition of those electrolytics is in. Everything's all washed out again. I'm thinking about getting a different camera because I think the exposure on this keeps changing. 33 looks good. 100 looks good. And check and see if this had a short or anything like that. I'll test what you'd about figure. So, long story short, other than a loose connection we found on the plate of the oscillator tube, this board checks out. All the resistors are within tolerance. These two capacitors, just okay, nothing shorted. Although that resistor looked kind of crappy, it's fine. Just going over this again really quick with the eye, I don't see any additional loose connections. I suppose as a good measure, I'll resolder the pins that connect the board, because they can get crummy. and the socket bit down nice and tight, so I don't think the socket's at fault. Although I could spray a little contact cleaner into the socket. I am going to test the pots and make sure the pots aren't open, because obviously if we have an open pot we have a problem there. Alright, so you're already soldered there. I'm going to go ahead and we'll spritz a little bit of contact and control cleaner on these pins. And then we'll put this back in. Assuming it'll let me do that. And the best way to get these back in without breaking them is with a socket driver, and I'll just gently push over the pin like that, and I'll try to seat it. That way I don't end up breaking anything of importance, because you don't want to put too much stress on any given part of this, otherwise things will break and then you'll be having to fix that too. Let's see here, let's put the vertical output tube back in. Those sockets bite down really tight, so I don't think it's a loose socket, although that plate connection on this oscillator was loose. Okay, so the next thing I'm going to do before we give it a shot again is I'm going to test these potentiometers and make sure they're not open. So here's our vertical linearity, and this is measuring across the resistive element by itself, not the wiper. That looks like a 10K. And we've got, they got two terminals tied together, so that's why there's the short. And we've got 10K there, or 11K. So does that mean somebody turned the pot in one direction? That's kind of what it looks like to me. They had it marked here where it was originally. 14K. It does adjust. A little touchy there at the bottom, but it does adjust. Put it back where we found it. And then the vertical size, that's a little bit trickier to get to. $215. Let's see if they got two shorted together here. Can't even get to that part. $227 there from wiper to far side. $215 there from wiper to the other side, so that's probably halfway. That was actually turned almost all the way down, or maybe it was all the way up, who knows. Let's just clean them both just for grins and giggles. Why not? I'm going to set them both at midpoint. Okay, let's apply some power to this thing and see if any of our efforts have been positive in getting the vertical restored. Okay, well, let's see if any of our troubleshooting and efforts made any bit of difference here. We're going to see if our vertical starts this time. Nothing yet. Oh, look at that, we got a field. That's pretty cool. So even with those two weak tubes, you can see we've got a full field now. There's channel 6. The horizontal frequency is a bit off. Sounds a little distorted. Hear that horizontal singing. Now if I turn the horizontal hold, oh, there we go. Then the red keeps flickering on and off. Let's adjust our vertical now. I'm probably not going to be able to lock the vertical in until I get the settings dialed in. That and the weak station pretty much presents no sync. Let's see if I can adjust the vertical field at all. And then I've also got pretty weak contrast. We're going to try to attempt to adjust the vertical here, assuming I can find a tool that'll get inside there. And I keep getting those flashes of red. Nope, that's not doing it for me. Let's try a different tool. Something with a wider blade, maybe. Nope. Still nothing yet. I can't seem to get the... There we go. It's obviously at one extreme. And I've got excess linearity at the top. Okay. These user adjustments have this tiny little slot in them. Certainly isn't easy to adjust. Alright, well, trying to get that balanced out. Oh, look, it stops rolling. So we've got bad video for sure. The video response on this really is terrible. I mean, that could be because of a dirty pot. There is an AGC adjustment on the back. Automatic gain control. Let's see if that does anything useful. Come on. Yeah, there's none. That's the AGC cranked all the way up. So, and then turning it down, you lose raster or lose picture altogether. No color, obviously. I think we got bigger things to worry about at this point. But we're making progress. Let's see if we can dial in that vertical size anymore. Probably not. These pots have this tiny little slot in them. And most of the tools I have and every time I adjust the vertical size it goes nuts. Roll, roll, roll your boat. Okay, so that's where we're at so far. So bad connection on the oscillator for the plate. And then I just cleaned the pots, but the pots nominally tested okay. So as you can see now, we got a picture. It still needs a lot of help, but we're getting there. So I hope you guys enjoyed part 1. Part 2, we'll get back into this. We'll clean the tuner and all the pots and everything. Check and maybe replace some more tubes. And hopefully we can establish a better picture and figure out why the red keeps flickering on and off. That could be a problem in the picture tube. That could be a RY amp or something like that. I don't know. But that's where we're at so far. Pretty cool. So I hope you guys enjoyed this segment. Stay tuned for the next part.